CIET NCERT presents Audiobook of Science for Class 7 entitled Science. This is the lesson 8 entitled Winds, Storms and Cyclones from page 81 to 95. Let's listen to the lesson 8 Winds, Storms and Cyclones. Page 80. Orissa was hit by a cyclone with wind speed of 200 kilometers an hour on 18th October 1999. The cyclone smashed 45,000 houses, making 7 lakh people homeless. On 29th October the same year, a second cyclone with wind speeds of 260 kilometers an hour hit Orissa again. It was accompanied by water waves about 9 meters high. Thousands of people lost their lives. Property worth crores of rupees was destroyed. The cyclone affected agriculture, transport, communication, and electricity supply. Figure 8.1. Image taken by a satellite of a cyclone approaching the coast of Orissa. Courtesy Indian Meteorological Department, New Delhi. But what are cyclones? How are they formed? Why are they so destructive? In this chapter, we shall seek answers to some of these questions. We begin with some activities involving air. These activities will clarify some basic features concerning a cyclone. Before we begin, remember that moving air is called the wind. 8.1. Air exerts pressure. Activity 8.1. Whenever an activity involves heating, be very careful. It is advised that such activities are performed in the presence of an elderly person from your family, or carry out these activities in the presence of your teacher. You need to boil water in the following activity. Take a tin can with a lid. Fill it approximately half with water. Heat the can on a candle flame till the water boils. Let the water boil for a few minutes. Blow out the candle. Immediately put the lid tightly on the can. Be careful in handling the hot can. Put the can carefully in a shallow metallic vessel or a wash basin. Pour fresh water over the can. What happens to the shape of the can? Page 81. Figure 8.2. Can with hot water being cooled. In this figure, we can observe on the left hand side there is a can filled with water being heated by a lit candle under it. On the right hand side, when a fresh glass of water was poured on the same can with boiling hot water, the can got distorted. Can you guess why the shape of the can gets distorted? If you cannot get a tin can, take a soft plastic bottle. Fill it with hot water. Empty the bottle and immediately cap it tightly. Place the bottle under running water. Recall now some of your experiences. When you fly a kite, does the wind coming from your back help? If you are in a boat, is it easier to row if there is wind coming from behind you? Do you find it difficult to ride a bike against the direction of the wind? You know that we have to fill air into the bicycle tube to keep it tight. Also, you know that a bicycle tube overfilled with air may burst. What is the air doing inside the tube? Discuss with your friends how the air in the bicycle tube keeps it in shape. All these experiences show that the air exerts pressure. It is due to this pressure that leaves of trees, banners, or flags flutter when the wind is blowing. You can list some more experiences which show that the air has pressure. Let us now try to explain why the can or the bottle gets distorted. As water is poured over the can, some steam in the can condenses into water, reducing the amount of air inside. The pressure of air inside the can decreases than the pressure exerted by the air from outside the can. As a result, the can gets compressed. This activity again confirms that air exerts pressure. 8.2. High-speed winds are accompanied by reduced air pressure. Activity 8.2. Crumple a small piece of paper into a ball of size smaller than the mouth of an empty bottle. Hold the empty bottle on its side and place the paper ball just inside its mouth. Now try to blow on the ball to force it into the bottle. Try the activity with bottles of different sizes. Challenge your friends if they can force the paper ball in by blowing into the bottle. Figure 8.3. Blowing into the bottle. We can observe the picture of a child with a bottle in his hand. There is a crumpled piece of paper inside the bottle. He is trying to push the crumpled piece of paper inside the bottle by blowing inside its mouth. Page 82. Paheli and Bojo are thinking about the following question. Why is it difficult to force the paper ball into the bottle? Activity 8.3. Blow the balloons. Take two balloons of approximately equal size. Put a little water into the balloons. Blow up both the balloons and tie each one to a string. Hang the balloons 8 to 10 centimeters apart on a cycle spoke or a stick. Blow in the space between the balloons. What did you expect? What happens? Try different ways of blowing on the balloons to see what happens. Figure 8.4. Blowing between the balloons. Here we can observe a child holding a stick. There are two blown up balloons attached to the stick 8 to 10 centimeters apart from each other. The child is trying to blow air between both the balloons. Activity 8.4. Can you blow and lift? Hold a strip of paper 20 cm long and 3 cm wide between your thumb and forefinger as shown in figure 8.5. Now blow over the paper. Paheli thinks that the strip will be lifted up. Bojo thinks that the strip will bend down. What do you think will happen to the paper? Figure 8.5. Blowing over a strip of paper. There are two images here. In the first one, a person is holding a strip of paper between his thumb and his forefinger. In the second one, he is blowing air over the strip of paper. In the second image, the strip of paper makes a wave-like pattern. Let us try to understand the observations in activities 8.2, 8.3 and 8.4. Were the observations along the lines you thought? Do you get the feeling that the increased wind speed is accompanied by reduced air pressure? When we blow into the mouth of the bottle, the air near the mouth has higher speed. This decreases the pressure there. The air pressure inside the bottle is higher than the mouth. The air inside the bottle pushes the ball out. In activity 8.3, you saw that when you blew between the balloons, they moved towards each other. Page 83. How could this happen? This could happen if the pressure of the air between the balloons were somehow reduced. The pressure outside the balloons would then push them towards each other. In activity 8.4, you saw that when you blew over the paper strip, it went upwards. Again, this could only happen if blowing over the paper reduced the air pressure above the strip. We see that the increased wind speed is indeed accompanied by a reduced air pressure. Can you imagine what would happen if high-speed winds blew over the roofs of buildings? If the roofs were weak, they could be lifted and blown away. If you have any such experience, share it with your class. Let us try to understand how winds are produced, how they can bring rain, and how they can be destructive sometimes. You already know that when air moves, it is called wind. Air moves from the region where air pressure is high to the region where air pressure is low. The greater the difference in pressure, the faster the air moves. But how are the pressure differences created in nature? Is the difference in temperature involved? The following activities will help you understand this. 8.3. Air expands on heating. Activity 8.5. Take a boiling tube. Stretch a balloon tightly over the neck of the tube. You can use a tape to make it tight. Pour some hot water in a beaker. Insert the boiling tube with the balloon in the hot water. Observe for 2 to 3 minutes for any change in the shape of the balloon. Take the tube out. Let it cool down to the room temperature. Take some ice cold water in another beaker and place the tube with the balloon in the cold water for 2 to 3 minutes. Observe the change in the shape of the balloon. Think and try to answer. What makes the balloon inflated when the boiling tube is placed in hot water? Why is the same balloon deflated when the tube is kept in cold water? Can we infer from the first observation that the air expands on heating? Can you now state what happens to the air in the boiling tube when it cools down? Figure 8.6. The shape of the balloon in hot and cold water. In this figure, we can observe 3 different boiling tubes with balloons wrapped around their necks sitting in 3 different beakers. In the first image, the balloon is regularly suspended on a boiling tube. In the second image, where the boiling tube is immersed in hot water, the balloon has risen up. In the third image, where the boiling water is immersed in ice-cold water, the balloon has shrunken in. Page 84. The next activity is very interesting. This will make you understand more about hot air. Activity 8.6. Take 2 paper bags or empty paper cups of the same size. Hang the 2 paper bags in the inverted position on the 2 ends of a metal or a wooden stick. Tie a piece of thread in the middle of the stick. Hold the stick by the thread as in a balance. This can be observed in figure 8.7. Put a burning candle below one of the bags as explained in the figure. Observe what happens. Why is the balance of one of the bags disturbed? Does this activity indicate that warm air rises up? As the warm air rises up, it pushes the bag above the candle. Does the disturbance of the balance suggest that warm air is lighter than cold air? Can you now explain why smoke always rises up? Also, it is important to remember on heating, the air expands and occupies more space. Where the same thing occupies more space, it becomes lighter. The warm air is, therefore, lighter than the cold air. That is the reason that smoke goes up. In nature, there are several situations where warm air rises at a place. The air pressure at that place is lowered. The cold air from the surrounding areas rushes in to fill its place. This sets up convection in the air, as you learned in chapter 4. Caution: handle the burning candle carefully. Figure 8.7. Hot air rises up. In this figure, we can observe 2 different images. In the first one, 2 paper bags are suspended on a wooden stick and there is a thread in between the stick. In the second image, there is a burning candle under one of the bags. The bag under which the burning candle is kept rises above the other bag, tilting the wooden stick. 8.4. Wind currents are generated due to uneven heating of the earth. These situations are: A. uneven heating between the equator and the poles. You might have learned in geography that regions close to the equator get maximum heat from the sun. The air in these regions get warm. The warm air rises and the cooler air from the regions in 0 to 30 degrees latitude belt on either side of the equator moves in. Page 85. These winds blow from north and south towards the equator. At the poles, the air is colder than that at latitudes about 60 degrees. The warm air at these latitudes rise up and the cold wind from the polar regions rushes in to take its place. In this way, wind circulation is set up from the poles to the warmer latitudes, as observed in Figure 8.8. Figure 8.8. The wind flow patterns because of uneven heating on the Earth. There's a picture of Earth here and the wind flow patterns because of uneven heating are marked on top of it. There's a thought bubble here and a picture of Paheli is next to it. I wonder why the winds shown in the figure are not the exact north-south direction. The winds would have flown in north-south direction from north to south or from south to north. A change in direction is, however, caused by the rotation of the Earth. B. Uneven heating of land and water. You have read about the sea breeze and the land breeze in Chapter 4. In summer, near the equator, the land warms up faster and most of the time the temperature of land is higher than that of water in the oceans. The air over the land gets heated and rises.
This causes the winds to flow from ocean towards the land.
These are monsoon winds, which can be observed in Figure 8.9. The word monsoon is derived from the Arabic word mawsam, which means season. In winter, the direction of flow is reversed. It flows from land to the ocean. This can be observed in Figure 8.10. There's a thought bubble under this, and a picture of Bojo is next to it. I want to know what these winds do for us. The winds from the ocean carry water and bring rain. It is part of the water cycle. The monsoon winds carry water and it rains. Clouds bring rain and give us happiness. Farmers in our country depend mainly on the rains for their harvests. There are many folk songs associated with clouds and rain. Sing and enjoy with your friends if you know such a song. Here is one for you. Page 86. Roaring clouds across the sky tell us that monsoon is here. Dark and floating clouds then pour raindrops everywhere. Clouds make lightning flash overhead and irrigate fields with rain. Clouds make earth, its fragrance spread when wet with drops of rain. Rising from the ocean vast, clouds fill up with rain. Rain to ocean back at last to mingle with ocean again. However, it is not always a happy ending. Rains often create problems. Can you list some of those problems? You can discuss the causes and solutions of the problems with your teacher and parents. In nature itself, there are certain situations that can sometimes create disasters and pose threat to humans, animals, and plant life. Let's study two such situations: thunderstorms and cyclones. Figure 8.9. Uneven heating of land, especially the Rajasthan desert, generates monsoon winds from southwest direction in summer. These winds carry lots of water from the Indian Ocean. Figure 8.10. Uneven heating of land and water in winter generate winds from the northwest colder land. These colder winds carry little water, hence bring small amount of rain in winter. Courtesy India Meteorological Department, New Delhi. Page 87. 8.5. Thunderstorms and cyclones. Thunderstorms develop in hot, humid, tropical areas like India very frequently. The rising temperatures produce strong upward rising winds. These winds carry water droplets upwards, where they freeze and fall down again. The swift movement of the falling water droplets along with the rising air create lightning and sound. It is this event we call a thunderstorm. You will read about lightning in higher classes. If a storm is accompanied by lightning, we must take the following precautions. Do not take shelter under an isolated tree. If you are in a forest, take shelter under a small tree. Do not lie on the ground. Do not take shelter under an umbrella with a metallic end. Do not sit near a window. Open garages, storage sheds, metal sheds are not safe places to take shelter. A car or a bus is a safe place to take shelter. If you are in water, get out and go inside a building. How a thunderstorm becomes a cyclone. You know that water requires heat when it changes from liquid to vapor state. Does the water give back heat when vapor condenses into liquid? Can you recall any experience to support this? Structure. How a thunderstorm becomes a cyclone. You know that water requires heat when it changes from liquid to vapor state. Does the water give back heat when vapor condenses into liquid? Can you recall any experience to support this? Structure of a cyclone. The center of a cyclone is a calm area. It is called the eye of the storm. A large cyclone is a violently rotating mass of air in the atmosphere, 10 to 15 kilometers high. The diameter of the eye varies from 10 to 30 kilometers. This can be observed in figure 8.11. It is a region free of clouds and has light winds. Around this calm and clear eye, observable in figure 8.12, there is a cloud region of about 150 kilometers in size. In this region, there are high-speed winds, about 150 to 250 kilometers an hour, and thick clouds with heavy rain. Away from this region, the wind speed gradually decreases. The formation of a cyclone is a very complex process. A model can be observed in figure 8.11. Before cloud formation, water takes up heat from the atmosphere to change into vapor. When water vapor changes back to liquid form as raindrops, this heat is released into the atmosphere. The heat released into the atmosphere warms the air around. The air tends to rise and causes a drop in pressure. More air rushes to the center of the storm. This cycle is repeated. The chain of events ends with the formation of a very low pressure system with very high speed winds revolving around it. It is this weather condition that we call a cyclone. Factors like wind speed, wind direction, temperature, and humidity contribute to the development of cyclones. Page 88. Figure 8.11. Formation of a cyclone. In this figure, we can observe the visual representation of formation of a cyclone. This particular cyclone is 15 kilometers high. The eye of the cyclone is 10 to 30 kilometers in radius. The winds around the eye are moving in an anti-clockwise direction. The stream flow is from east to west. Same goes for the direction in which the cyclone is moving. On the right hand side of the cyclone, we can observe gales gradually decreasing. On the left, gales gradually increasing. We can also observe hurricane winds around the eye of the cyclone. We can also observe the outflow of air from the top of the cyclone. Figure 8.12. The image of the eye of a cyclone. Figure 8.13. Rising water caused by a cyclone. Courtesy India Meteorological Department, New Delhi. 8.6. Destruction caused by cyclones. Cyclones can be very destructive. Strong winds push water towards the shore even if the storm is hundreds of kilometers away. These are the first indications of an approaching cyclone. The water waves produced by the wind are so powerful that a person cannot overcome them. The low pressure in the eye lifts water surface in the center. The rising water may be as high as 3 to 12 meters, as observed in figure 8.13. It appears like a water wall moving towards the shore. As a result, the seawater enters the low-lying coastal areas, causing severe loss of life and property. It also reduces the fertility of the soil. Continuous heavy rainfall may further worsen the flood situation. High-speed winds accompanying a cyclone can damage houses, telephones and other communication systems, trees, etc., causing tremendous loss of life and property. Page 89. A cyclone is also known by different names in different parts of the world. It is called a hurricane in the American continent. In Philippines and Japan, it is called a typhoon. This can be observed in figure 8.14. Figure 8.14. Regions near the equator where cyclones form. Cyclones are a worldwide phenomena. Tornadoes. In our country, they are not very frequent. A tornado is a dark, funnel-shaped cloud that reaches from the sky to the ground, as can be observed in figure 8.16. Most of the tornadoes are weak. A violent tornado can travel of speeds about 300 kilometers an hour. Tornadoes may form within cyclones. The whole coastline of India is vulnerable to cyclones, particularly the east coast. The west coast of India is less vulnerable to cyclonic storms, both in terms of intensity and frequency of the cyclones. The diameter of a tornado can be as small as a meter and as large as a kilometer, or even wider. The funnel of a tornado sucks dust, debris, and everything near it at the base due to the low pressure, and throws them out near the top. Here are few accounts of survivors of tornadoes from Discovery Channel's Young Discovery series. I saw the cloud coming and tried to take shelter inside, but as soon as I reached for the doorknob, the house took off into the sky. I was not hurt at all. After the storm, we had to clean the debris from the wheat fields. We picked up splintered boards and tree branches, as well as dead chickens with their feathers blown off, and rabbits looked like they had been skinned. A tornado shelter is a room situated deep inside or underground having no windows, or otherwise it is better to shut windows and take shelter under a table, workbench where debris cannot reach. One has to bow down on knees, protecting head and neck using arms, as can be observed in figure 8.15. Figure 8.15. Protecting from a tornado. Here we can observe a child bowed down on his knees, protecting his head and neck using his arms. 8.7. Effective safety measures. 1. A cyclone forecast and warning service. 2. Rapid communications of the warnings to the government agencies, the ports, fishermen, ships, and to the general public. Page 90. 3. construction of cyclone shelters in the cyclone prone areas, and administrative arrangements for moving people fast to safer places. Action on the part of the people. 1. We should not ignore the warnings issued by the meteorological department through TV, radio, or newspapers. 2. We should make necessary arrangements to shift the essential household goods, domestic animals, and vehicles, etc., to safer places. Avoid driving on roads through standing water as floods may have damaged the road, and keep ready the phone numbers of all emergency services like police, fire brigade, and medical centers. Some other precautions if you are staying in a cyclone hit area. 1. Do not drink water that could be contaminated. Always store drinking water for emergencies. 2. Do not touch wet switches and fallen power lines. 3. Do not go outside just for the sake of fun. 4. Do not pressurize the rescue force by making undue demands. 5. Cooperate and help your neighbors and friends. 8.8. Advanced technology has helped. These days, we are better protected. In the early part of the last century, coastal residents may have had less than a day to prepare or evacuate their homes from an oncoming cyclone. Page 91. The world today is very different. Thanks to satellites and radars, a cyclone alert or cyclone watch is issued 48 hours in advance of any expected storm, and a cyclone warning is issued
24 hours
in advance. The message is broadcast every hour or half hour when a cyclone is nearest the coast. Several national and international organizations cooperate to monitor the cyclone-related disasters. Keywords: anemometer, cyclone, hurricane, lightning, low pressure, monsoon winds, pressure, thunderstorms, tornado, typhoon, wind flow pattern. What you have learned. 1. Air around us exerts pressure. 2. Air expands on heating and contracts on cooling. 3. Warm air rises up, whereas comparatively cooler air tends to sink towards the Earth's surface. 4. As warm air rises, air pressure at that place is reduced and the cooler air moves to take that place. 5. The moving air is called wind. 6. Uneven heating on the earth is the main cause of wind movements. 7. Winds carrying water vapor bring rain. 8. High-speed winds and air pressure difference can cause cyclones. 9. It has become easier to monitor cyclones with the help of advanced technology like satellites and radars. 10. Self-help is the best help. Therefore, it is better to plan in advance and be ready with defense against any approaching cyclone. 11. The following flowchart will help you to understand the phenomena that led to the formation of clouds and falling of rain and creation of storms and cyclones. Page 92. There is a flowchart given here. At the top of the flowchart, we have difference of temperature between two regions. Below that, sets convention in air. Warm air rises, creating a low pressure area. Cool air converges to the low pressure area. Warm air rises, cools, and the water vapor condenses to form clouds. The bigger water drops in the clouds fall to the ground as rain, hail, or snow. Falling water droplets and rising air move vigorously to produce thunderstorm. Under certain weather conditions, storms may develop into cyclones. Exercises 1. Fill the missing word in the blank spaces in the following statements. A. Wind is blank air. B. Winds are generated due to blank heating on the earth. C. Near the earth's surface, blank air rises up whereas blank air comes down. D. Air moves from a region of blank pressure to a region of blank pressure. 2. Suggest two methods to find out wind direction at a given place. 3. State two experiments that made you think that air exerts pressure other than those given in the text. 4. You want to buy a house. Would you like to buy a house having windows but no ventilators? Explain your answer. 5. Explain why holes are made in hanging banners and hoardings. 6. How will you help your neighbors in case cyclone approaches your village or town? 7. What planning is required in advance to deal with the situation created by a cyclone? 8. Which one of the following place is unlikely to be affected by a cyclone? 1. Chennai. 2. Mangaluru or Mangalore. 3. Amritsar. 4. Puri. Page 93. 9. Which of the given statements below is correct? 1. In the winter, the wind flows from the land to the ocean. 2. In the summer, the wind flows from the land towards the ocean. 3. A cyclone is formed by a very high pressure system with very high speed winds revolving around it. 4. The coastline of India is not vulnerable to cyclones. Extended learning, activities and projects. 1. You can perform the activity 8.5 in the chapter slightly differently at home. Use 2 plastic bottles of the same size. Stretch one balloon on the neck of each bottle. Keep one bottle in the sun and the other one in the shade. Record your observations. Compare these observations and the result with those of activity 8.5. 2. You can make your own anemometer. Collect the following items. 4 small paper cups or used ice cream cups. 2 strips of cardboards 20 cm long and 2 cm wide. Gum, stapler, a sketch pen and a sharpened pencil with a razor at one end. Take a scale. Draw crosses on the cardboard strips as observed in figure 8.18. This will give you the centers of the strip. Figure 8.18. Finding center of the strips. Here we can observe a rectangle. The non-adjacent corners of the rectangle have been joined to obtain 2 diagonals. The point where the 2 diagonals meet is the center of the rectangle. Figure 8.19. A model of an anemometer. In this figure, we can observe a pencil passing through 2 strips with cups attached on both the ends. such that the cups all face the same direction and the strips can move freely. Page 94. Fix the straps at the center, putting one over the other so that they can make a plus sign. Now fix the cups at the ends of the strip. Color the outer surface of one cup with a marker or a sketch pen. All the 4 cups should face the same direction. Push a pin through the center of the strips and attach the strips and the cups to the eraser of the pencil. Check that the strips rotate freely when you blow on the cups. Your anemometer is ready. Counting the number of rotations per meter will give you an estimate of the speed of the wind. To observe the changes in the wind speed, use it at different places and different times of the day. If you do not have a pencil with attached eraser, you can use the tip of a ball pen. The only condition is that the strips should rotate freely. Remember that this anemometer will indicate only speed changes. It cannot give you the actual wind speed. 3. Collect articles and photographs from newspapers and magazines about storms and cyclones. Make a story on the basis of what you learnt in this chapter and the matter collected by you. 4. Suppose you are a member of a committee which is responsible for creating development plan of a coastal state. Prepare a short speech indicating the measures to be taken to reduce the suffering of the people caused by cyclones. 5. Interview eyewitnesses to collect the actual experience of people affected by a cyclone. 6. Take an aluminium tube about 15 cm long and 1 to 1.5 centimeters in diameter. Cut slice of a medium-sized potato about 2 centimeters thick. Insert the tube in the slice. Press it and rotate it 2 to 3 times. Remove the tube. You will find a piece of potato fixed in the tube like a piston head. Repeat the same process with the other end of the tube. Now you have the tube with both ends closed by potato pieces with an air column in between. Take a pencil with one end unsharpened. Place the end on one of the pieces of potato. Press it suddenly to push the potato piece in the tube. Observe what happens. The activity shows rather dramatically how increased air pressure can push things. Figure 8.20. In the first image here, we can see someone pushing a metal tube through a slice of a potato. In the second image, someone is pushing a pencil into one of the pieces of the potatoes, launching the other one in the air. Caution: when you perform this activity, make sure that no one is standing in front of the tube. Page 95. You can read more on the related topics on the following website: http://www.imd.gov.in/. Did you know a bolt of lightning travels at a speed of more than 4 lakh kilometers an hour? It can heat the air around it to a temperature which is more than 4 times the temperature of the surface of the sun. That is what makes lightning so dangerous. The chapter 8 of total 18 chapters ends here.
Narrator